So welcome to Mathematics. Today we are on the MIT Integration Bee 2026 Semifinals number 1, problem number 2, which is the indefinite integral of x squared minus 2 over x squared plus 2 times the square root of x to the fourth plus 4, and we're integrating in terms of x. So this is a very interesting problem. Let's see how we may be able to solve this. So the first thing we'll do here is we'll divide both the numerator and the denominator by x squared, right? And so what results from this is we do have as the integrand 1 minus 2 over x squared over x plus 2 over x times the square root of x squared plus 4 over x squared. Now, as you can see, this numerator here happens to be the derivative of x plus 2 over 2x, such that we could now go ahead and say let u be equal to x plus 2 over x, and that means that du dx is 1 minus 2x squared. So we can substitute 1 minus 2 over x squared dx with du. So this is interesting. What we're going to do is we're going to substitute the numerator times dx with du. However, let's try to reorganize what is inside the square root sign. So x squared plus 4 over x squared is the same as x plus 2 over x, all that squared, minus 4. So as you can see, there is u here, there is u here. And then whatever is the numerator is du. So with that in mind, we can, maybe to make it a little bit more explicit, we'll just do color coding and do the substitution. So we're going to do a little bit of color coding. 1 minus 2x squared dx is du. X plus 2x is going to be u, which is in green. And so as you can see, we have put du and u as in green. And this is because we said u was the same as x plus 2x and du equals to 1 minus 2x squared dx. So with that in mind, we can also go forward and do a further substitution by saying let u be equal to 2 secant theta, meaning that du d theta is equals to 2 sec theta tangent of theta. And so we can substitute du, or for du with 2 secant theta tan theta d theta. With that in mind, du now has been substituted with 2 secant theta tan theta d theta, and u is 2 secant theta, u squared is 4 sec squared theta minus 4. Now using the trigonometrical identity such that even before we go ahead, we can pull the 4 out so that we are left with sec squared theta minus 1 under the square root sign. And also sec squared theta minus 1 is tangent squared theta. Square root of that we have tangent theta. So we see that the numerator and the denominator could cancel out, and we are left with the integral of 1 with the constant half outside the integration sign. So this results into half theta plus the integration constant c. Since u was set to 2 secant theta, that means that theta is the arcsecond of u over 2, and that means that we now have the integration in terms of u as being half arcsecond of u over 2 plus the integration constant. But initially, we had also set u to be equal to x plus 2 over x. and that means that our final integral is half arcsecond x plus 2 over x over 2 plus integration constant c. Reorganizing everything, we see that our integral is half arcsecond of x squared plus 2 over 2x plus the integration constant c. And that was the final answer. We could express in terms of the arctangent or arc cosine, whatever is interesting to you would still suffice. So without much ado, that brings us to the end of our problem today. If you have any question in regard to this problem or any other problem that we saw previously, please don't hesitate to reach out to us. Bye-bye.